Welcome to Study Loop.
All right, our question says, a projectile is shot from the edge of a cliff 115 meters above the ground level with an initial speed of 65 meters per second at an angle of 35 degrees with the horizontal, as shown in figure 44. Then it says, A, determine the time taken by the projectile to hit point P at the ground level. B, determine the distance x above point P from the base of the vertical cliff at the instance just before the projectile hits point P. Find C, the horizontal and vertical component of the velocity. And D, the magnitude of the velocity. And E, the angle made by the velocity vector with the horizontal. F, find the maximum height above the cliff top reached by the projectile. So we're going to approach this one step at a time and kind of solve it out that way. Okay, A, B, C, D, E, F, because they kind of build on one another. And we're going to choose the origin to be at ground level under the place where the projectile is launched, and upward to be the position Y direction. So for the projectile, which I have written out here, V naught is equal to 65 meters per second. Theta naught is equal to 35 degrees, which is the initial angle. And then Y naught is equal to 115 meters. And first, we want to figure out A, the time it takes to reach the ground level, which we can do using equation 2-12b with the final height equal to 0. So, because the ground level is going to be equal to 0. So let's write out this is A. So we'll just say this is A. A is equal to Y equals Y naught plus Vy naught times the time plus 1/2 A times the time squared, where A is the acceleration. Okay, now we'll plug in what we know here, right? Just to kind of simplify this a little bit. Well, it's going to hit ground level, so that's going to be equal to 0 equals, so because Y is equal to 0, Y naught, which was 115. Well, we'll just keep this in terms of the variables because otherwise we're going to be doing a lot of writing with numbers. So Y naught plus Vy naught, which is Vy naught is equal to the initial velocity times the sine of the angle theta naught. Okay, multiplied by t still, plus 1/2. I'm sorry, this is actually going to be minus now because of gravity, because we're going to include gravity's play in this. So change this plus sign to a minus 1/2, where the acceleration is gravity, times t squared. Well, we can use the quadratic formula here to solve for t. T then would be equal to minus v naught times the sine of theta naught plus or minus the square root of v naught sine theta naught squared. So v naught squared sine squared theta naught minus 4, and that's going to be times y naught multiplied by the minus 1/2 g. Okay. All this is under the square root, so we'll extend that. All this then is divided by 2 times minus 1/2 g. And because of the plus or minus, you're going to get two answers. The first answer is going to be 9.964 seconds. And the second answer is going to be equal to minus 2.3655 seconds. Well, it doesn't really make sense to have a negative time, so we're just going to include the positive time. And to the correct number of significant digits, this is approximately 9.96 seconds. Okay. Now let's do part B. And if we reread the question here, part B says to determine the distance x at point P from the base of the vertical cliff. All right, so in order to do that, we can use the horizontal range by, or we can find the horizontal range from the horizontal motion at a constant velocity. Okay, so let's do that. We're going to use this equation. Let's label this as part B, where the distance traveled is equal to x, which is v of x times the time traveled. Well, we just found the time traveled in the previous equation, and v of x is v naught times the cosine of theta naught. And again, this is times time. Well, if we look at the previous page, v naught is 65 meters per second, theta naught is 35 degrees, and time, which we solved for previously, is 9.96. So we plug all of these in, and we find that this is equal to 531 meters. Okay, box that in as our solution to part B. Now, part C, if we go back and read our question, says to, give me just a second here. It says to, at the instant just before the projectile hits point P, find the horizontal and vertical components of the velocity. So we want to find v of x and v of y. Well, we already have v of x written in the equation above, right? V of x, we said, was equal to v naught times the cosine of theta naught. And that's equal to v naught, again, was 65 meters per second times the cosine of 35 degrees. And that is equal to 53.2 meters per second. Okay. And for the second part of part C, it wants us to do the same thing for v of y. Well, v of y is equal to the initial velocity in the y direction, and then plus the acceleration times the time in that direction. Okay, and the acceleration is gravity, of course, and v naught is in the y direction is v naught times the sine of the angle theta naught. And then a of t is minus g, or I'm sorry, a is minus g, so then a of t is minus g of t. Okay, well, v naught, again, is 65 meters per second. Theta naught is 35 degrees. G is 9.8 meters per second squared. T, we found on the previous page, was 9.96 seconds. So if you plug all of that in, you find this is equal to minus 60.4, and that's meters per second. Box that in as part C solution. Then for part D asks us to find the magnitude of the velocity. Well, the magnitude of the velocity is just equal to the square root of the sum of the squares of the two components that make it up, which are v of x squared and v of y squared. Okay, well, above is v of x and v of y, 53.2 squared plus negative 60.4 squared. And then you take the square root of all of that, and you find this is equal to 80.5 meters per second. And then part E here, if we go back to the question, asks us to find the angle made by the velocity vector with the horizontal. Well, in order to do that, let's go ahead and draw out this scenario so we know what angle we're talking about. So if we draw out our triangle, which is a right triangle, we have this angle theta from v of y, v of x, and v. Therefore, using our trigonometric identities, the tangent of that angle is going to be equal to v of y divided by v of x. Tangent theta is opposite over adjacent. Therefore, theta is equal to the inverse tangent of v of y and v of x, which we found on the previous page, So you plug those values in, and you find that theta is equal to minus 48.6 degrees. Okay. Now, for part F, it wants us to find the maximum y value, right? Okay, so the maximum y value we can find using equation 2-12c. This is part F, which says that v of y squared is equal to v of y naught squared plus 2ay times y minus y naught. Okay, and at maximum, v of y is equal to 0, right? So since we're trying to solve for at maximum, we have 0 is equal to v of y naught is, of course, v naught, v of y naught squared anyways, of course, is v naught squared sine squared of theta naught. And this is minus, because a is minus g, so this is minus g, and then y minus y naught. Well, y naught is equal to 0, so this is y max. Okay, so we solve for y max. We'll just abbreviate it as ym for y max. We find that this is equal to v naught squared sine squared of theta naught divided by 2 times the gravity. And if you plug all that in, remember theta naught is 35 degrees, v naught is 65 meters per second, we find that the maximum y value is 70.9 meters. Box that in.